Hello friends, welcome back to this channel. In this video we will see the first method, that is called bisection method. But before that we will list out the various methods that we are going to learn in this video lecture series in case of finding the root of the equation, right? So all these are the iterative method for finding the root of the equation. So what do we understand by iterative method? In every iteration we will find a new approximated root which is moving near to the actual root, right? So iteration by iteration we will find the updated new approximated root that is moving towards the actual root. So there are basically two types of method. First one is called bracketing method and open method. In bracketing method, one is the bisection method, also known as halving method or binary search method, and second is a false position method, also known as a regular falsy method, and second is a open method. So in open method, first one is a Newton-Raphson method, then secant method, and simple fixed point iteration method. So in bracketing method, what does it mean? Root of the particular equation will lie between this bracket. So one bracket is given to you, so our root will lie within that bracket only, while in open method there is no such condition. We can start with any initial guess x0 and we are moving towards the root of the equation using iteration by iteration. All right, so let's understand the first method, bisection method. So let's draw one function over here. Let's say this is our x, this is our f of x, and a particular function is drawn over here. This function is f of x. The function is f of x. Now we know the function value at a 2 interval. Let's say this is the interval a, lower limit. This is the interval b, higher limit, right? So we know this interval a and b. So in bisection method, a function f of x is given and bracket a comma b is given. So since it is a bracketing method, the root will lie within this interval, right? So actual root of the function is this point. This is the actual root of the function, and our objective is to find out this root, to find out the actual root using this bisection method, right? So first condition, so using this bisection method we approximate new approximated root c is equals to a plus b by 2, right? So we assume that our new root is at a distance of a plus b by 2. Let's say the c point is over here, right? We find the function value at that point, f of c. So f of c is positive over here, f of a is negative over here. So now our root will lie in the interval a and c, So this is our updated interval. So our root will lie between A and C. So in the next iteration we will assign or replace old value of B with new value of C. Old value of B with new value of C, right? So in the next iteration this interval again will be half by using the C is equals to A plus B by 2, right? So that way we are moving towards the root of the equation. I hope you are getting the concept of bisection method. Now note how to replace this variable. So if f of a into f of c is less than 0, so if f of a into f of c is less than 0, then root lie between A and C. F of A into F of C. So one of the condition that we have to check is that the multiplication of F of A into F of C. So this is only true when either F of A is negative and F of C is positive, or either F of A is positive and F of C is negative, right? Then and then the multiplication of these two terms will be less than 0. So in that case our root will lie between A and C. So in this our case f of A is negative because it is lying below the reference line, below the x-axis, and similar way f of C is positive which is lying above the reference line or above the x-axis, right? So our root will lie between A and C and replace B equal to C. Replace B equal to C. In second case, if f of A into f of C is greater than 0, then root lie between B and C and replace A equal to C. So remember these two conditions. This will be also used while doing the programming. Even we can convert this manual process into programming. We will see that later on. So, and in third case, if f of A into f of C equal to 0, then C is the root of the equation. Root of the equation. Right? So I hope you understand the concept of bisection method, how the interval will change depending on the function value. Let's list out the advantages and disadvantages of bisection method. So advantages of bisection method is, the first one is root is bracketed within bounds of interval. So method is guaranteed to converges. So right, many times what happens whenever we are dealing with this approximate methods, the solution may not converge, right? But bisection method will give you the guarantee that it will always converges. Though it is a very slow convergence is very slow, it might be for finding the solution is very laborious work, right? So second one is a maximum error in the root is bn minus an, a mode of bn minus an, where this can be calculated using b0 minus a0 divided by 2 raised to n, where n is nothing but the nth iteration, or bn and n is nothing but value of a and b after nth iteration. So let's say this is the bracket a and b. So each and every time this bracket will be half. So let's say this is our C, first value of C, right? Let's say the root will lie within this B and C. So again it will be half. This is the next value of C. Let's say that is C dash. Let's say again root is lie within this. So initially we have a two option. Root is lie within this ASC or BC, right? 2. Now we have a 4 option. Either root will lie between BC dash or C dash C, or either it will lie in this interval or in this interval. So in first iteration we have 2 option. Then in second iteration we have a 4 option. Similar way in third iteration we have 8 options. So 1, 2, 3, 4, 5, 6, 7 and 8. So each and every iteration our interval is divided by 2 raised to n time. So this equation comes from there. So using this n, we can approximate the number of iteration to achieve desired accuracy, right? We will use this equation later on. Then this disadvantages of this method is very slow converges, right? So other methods are usually faster. However, method always converges to solution, and for that reason it is often used as a starter method. So before using any other methods, this method will give us the guaranteed of convergence. So that's why many a times this method is used as a starting method, and then after some other method is used for finding the root of the equation. So I hope you understand the basic theory behind the bisection method. Do like, share and subscribe, and press the bell icon for latest notification, and we'll see you in the next video. Till then, goodbye.